Yeah.
Maths?
Yeah.
Yeah. You all uploaded?
But no cover sheet.
Ah, Jerry, I told you to put a cover sheet on it.
No? Oh, I have the cover sheet and the sign.
Did you upload it?
Yeah.
Ah, children.
那是我一开始没让他帮你啊，他帮我做的。
Okay. So like I said, this is good. It's Monday morning. We're back from the holidays, and we have something easy to do.
You have 8-hour chemistry class.
I don't.
Tomorrow?
Tomorrow?
No, this week.
Oh, this week? Oh, that's fine. I thought 8 hours. That's fine. You, for somebody who likes chemistry, it's fine.
Nobody.
Why are you looking around? It's funny, 'cause as soon as I said somebody who likes chemistry, he went, no. Nobody in this room. Okay, averages. So, I think you all know this word average, but in fact, in maths, we have, 4 different types of averages. So, the word average is not enough by itself. We actually have 4 types of averages, which are called the mean average, the median average, the mode average, and then one I like to do, I call the midpoint average. Yeah, so
Where's the one?
mean.
Oh, mean.
Yeah. So I'll explain all of them, but I think you actually might know some of them already. So the first one is the mean average. Okay, so does anybody know what this is?
General average.
Yeah, but like how do you calculate it? What's the formula? Yeah, that's it. So if you have some data, we'll say x1, x2, x3, all the way up to xn. This average is equal to the sum of all the data divided by n. So this is the one that you learn about in primary school, right? I think you do this in elementary school even. Yeah. So for babies. It's funny because the hard stuff that we do here is what my lecturers at college, at university, used to call the baby stuff. So at university, you're saying, and you just do this integration. Even someone in kindergarten could do it. I just think it's funny. Okay, so that's the mean average, the one that you learn about in kindergarten and elementary school. Unfortunately, when people say average, they actually mean this one. But we really should be more careful because there are different types of averages. We should always say the mean average. Okay? So the second one, the median average. Now, does anybody know what this one is?
Wait.
That's actually a different average, which I don't know. I don't think we'll do that one. And we don't need to do that one, even if I did ask it, we don't need that one. No, we just need these ones. Not weighted, no, something else.
The middle value.
The middle value. Yeah, so how could you find it? Like, what would be the process?
Max plus min divided by 2.
Not quite. Yeah, so if we were to give the steps. So first you have your data, x1, x2, x3, ... xn. Yeah, and then you want to order them. So here you have x, whichever one is the smallest. I'll call it x min. And then you have the next one, and the next one, and the next one, and then you finish on whatever is the maximum. So the median come on. The median is the middle one. Once you order it from smallest to largest. Okay. Now, that works well if you have an odd number. So, for example, if you have like x1, x2, x3, all the way up to x9, that's nice because the middle number is the fifth one. Yeah. But if you have even, so let's say you have up to x10, well, that's a little bit harder. What's the middle one there?
Between 5 and 6.
It's the middle of 5 and 6, so it's the fifth plus the sixth divided by 2. Yeah. Okay, so that's the median average. Got that? Okay, so we'll go on to the next one now. Number 3. The mode average, yeah. Okay, got that? So does anybody know the next one, the mode? Yeah. So what would be a more technical word to describe that?
The highest frequency.
Yeah. Yeah. What were you going to say, Monica? The same thing, yeah. So if you have x1, x2, x3, etc., then I should have written here the average is the median, yeah. So here, the average is whatever is the most frequent or the most common. So for example, maybe this is the number 7, and this is a 7, and this is a 7, and this is a 7, and 7 is the most common number, then the mode average is 7. It's just whichever one is the most common. Now you might say, what do you do if there are two numbers which are tied? So maybe you have a 777, and you also have an 888. What do you pick? Do you pick 7? Do you pick 8? Or neither? Or both? Or any?
Both.
What do you do? So you're saying you take both, not this. None of them actually, yeah. So it has to be number one. It can't be tied. It has to be clearly the most. Now what's interesting is different computer programs will give you a different answer. So for example, in Excel, if you had a tied situation, so firstly to explain, in a computer program, if you ask for the mode, it always gives you an answer, even if there is no mode. So what do you do if it's tied? So Excel, I think, will take the bigger number, so it will give you the 8. Whereas LibreOffice will take the number it finds first. So it depends which was first in your list, the 7s or the 8s. But both of those answers are wrong. Technically, if it's tied, there is no mode. It has to be clearly the most common. Okay. So if each number here was different, then there's no mode. Okay. And last one is what I call the midpoint average. Right. So how do we get this one? Do you think? That's it, yeah. So this average will be the smallest value plus the largest value over 2. Yep. Got that? Now, you might say, why are there different ways to calculate the average? So does anybody know? Like, why do we have different ways? Yeah, it's because it can be different, yeah. So actually, each average suitable for different situations. So what I'm going to do is I'm going to make up some data and I'm going to show you how your answers can be quite different. So if somebody asked you for the average, you should say, which average? Okay? Because different situations require different averages to be used. Okay. So we'll do 4 examples now. So the first one, the mean average. What might be some good data to use? Or what data should you have if you want to calculate the mean average? So what data should you have, you should be looking at if you're calculating the mean average?
Our grade.
Could be grade, yeah. So like if you have like 5 or 6 different exams, maybe you want to know your average, so the mean average would be good for that, yeah. Or like you said, age in the classroom perhaps, yeah. What else? GDP of what?
Country.
Yeah, but if it's an average, you mean like many countries or one country? Many countries? Which one? One country.
Isn't GDP already?
Yeah, GDP is already a type of average. I'm not sure how they calculate it though. Something else.
Percentage of victory in games.
Yes. Very specific, but yes. Okay, good. So we know when we could use it, but when not to use it. It's maybe a harder question. What data would not be suitable for the mean average?
Age.
No, age is okay.
But we don't say 15.5 age.
No, we can.
The minimum and maximum.
Speed's okay.
Tensor, now you distribute the tensor, you can't take like half.
No, this isn't a problem. This is fine. What are you saying?
The maximum and the minimum is huge difference.
Yeah, that's it. Very good, yeah. We shouldn't use it when the data has very strange maximums or minimums. So give me an example. What might be an example, Jerry? I know of data, I mean.
Like
Yeah, infinity would definitely be a problem, yeah.
1 to 1 to 1 to 1 to 1 total.
No, like what in real life? Like where could you see data that might be a problem?
Your age is 48 years old.
No. Firstly, that's not true, and secondly, the maximum age is never going to be so different to the rest that it causes a problem.
Energy.
Of what now?
Organism.
No, come on.
Ionization.
No. Think about a list of numbers that has very big different. The maximum is so different to the rest.
It's balanced.
No. You need to think about data where most of the numbers are kind of close together, but then you have a few numbers which are huge. Wait, no. Money, finally, money. Income.
Oh,
Yeah. Watch. So, let's imagine we have a small country of 10 people. Okay? So, this small country, we have a few poor people. A village, yeah. 20,000 a year. Okay, so we'll say, let's see.
A year.
A year? Yeah, a year. Okay. So these are small village. They have a few farmers. Then you have let's say some traders. So let's say we have one trader that does okay for themselves, and another trader which does that trader does well for themselves. But let's say we have one person who lives on the island because they won millions of euros, and they looked at this little island and said, I want to live on this island and retire here and buy the island. Okay, so maybe they won something like 50 million. And they move to this island. Now they own the island, and they live with all the other people here on the island. So, if I was to calculate the mean average, let's see what I would get.
20,000.
Mean average.
40,000. 50,000.
I think.
It comes 50,000.
5 million. 5 million. So if I told you, I know this little island, we'll call this island, I don't know, Stephen Island or something. And on this island, people do quite well. They have an average income of 50 million.
Oh, that's a really...
It sounds good, but when you actually look at the island, you realise, it's not great. In fact, most of the people on the island would not be close to 50 million. Is it 5 million or 50? Oh, 5 million, sorry. 5 million. Yeah? So this is one problem with the mean average. You have this one person here which is throwing off the total hugely. Now this is actually a big problem in my opinion when you listen to governments give statistics on how the economy is doing. Because the government wants to be seen as being good, they often report the mean average. But this is bigger than really what it should be because of the few people that earn so much. So when a government tells you the average, they're probably telling you the mean average, and they're doing this on purpose to make it look better. So if I was the government of this island, I'd say everyone on my island's doing great. The average income is 5 million a year. There's no problems. Everything's great. Yeah. Malaysia has an election coming up, doesn't it?
Mm-hmm.
You can listen to what averages they might give out for statistics. So the mean average is no good here. What might be better to use for income?
Max mean.
Mode and median and max min. In fact, the other three would be better. Well, not max min actually, but median would be very good. So let's get the median here. So first I should order this. Data, sort, ascending. Okay, so now you see you go from poorest to richest. And who is the middle one here? The middle one would be between 5 and 6, which actually is 20,000 plus 20,000 divided by 2, which is 20,000. Yeah. Okay, that's fine. The other one we could do is the mode average, which in this one here, who's the most common? Still 20,000. And the last one is the mid. And this is actually the worst one, because it will be this guy plus this guy divided by 2, which is 25 million.
Wow, yeah, so rich.
So this is the problem with the sentence. If I say the average is 5 million, the average is 20,000, the average is 25 million, all those are right. But I need to say is the mean, the median, or the mode. Yeah. So first one, let's look at when it's good and when it's bad. So it's definitely bad for income, but it's good for things in science, like average height, average weight, average voltage, things like this. Sean, come on, listen to me. Okay, let's go on to the median. So when is the median good to use? Well, actually, the median is good for exactly this when you have income. Yeah?
But there is 50 millionaires, so none of them are used right.
No, this is the problem. Whenever you use statistic, you're summarizing the data. And the moment you summarize data means you lose something. The only way you don't lose something is if you give all the data. But if I need to summarize this data, the moment I summarize it, I lose something. You can't, there's no way to avoid this. It's a bit like JPEGs. You know JPEG images? When you save a JPEG, it becomes a lot smaller. But when you zoom in, you can see it's pixely. you lose something when you compress it. So this is kind of how I think about a statistic. It compresses the data into one number, but then of course you lose stuff. What's bad for median?
Very good.
Yeah, I suppose it would be bad for science because when you want to have an accurate estimate and you have many measurements, you shouldn't just use the middle one. Although it's not actually that bad, so I suppose it would be bad for science. When is mode good?
Income.
No, yeah, but it was okay. It was okay here. It was okay here, but in real life, no, not everybody would have 20,000. Some would be 20,001, some would be 20,100. There might not be a mode if everyone has slightly different incomes.
Oui.
Huh?
Oui.
No, maybe not this. Yeah. So, shoe sizes. How many siblings you have. In other words, mode works really well when you have discrete data, like how many children, how many shoe size,
How many A's?
how many A's, how many B's. So mode works really well for when the data counts something. And what's it bad for? It's when the data is all the data is different. So, different data points. And that's really like science. Every measurement is usually different. Mid. Well, in fairness, it's good when, you want to be lazy and just have a quick estimate. If you have a lot of data and you just quickly want to have a rough estimate of the average, you could just look at the smallest, the biggest, and divide by 2. And it's bad really for everything. But its advantage is it's quick, it's easy, in your head you can estimate it very quickly. Now what's very interesting is, let me just replace these numbers for a moment with 10 different numbers. But I need to make up the numbers. Let me see. Let me generate some random numbers. 4. Come on. 100. Let's see if this program still works. So I'm going to make 10 random numbers if my program opens. Looks like it will.
Couldn't connect.
No, don't worry about this. It's just complaining. Right. Here we go. Right, great. Okay, let's see if I remember the command for this. It's been a while. Come on, don't be a jerk. Mind later. Come on. Oh, come on. There we go. Alright. Copy. Paste it in. Yeah. Oh no, it put it all in one column. Alright, I'll have to copy it one by one, sorry. 1, 2, 3, 4, isn't it? 5, 6. Now hang on to your seats now. 7, 8, 9, and 10. Right, now let's have a look here. Can you see the mean average, minus 0.15? Let's get the median. I'll have to sort these again. Data, sort ascending, current selection. Okay, so it's the middle of these two. So let me just add them together. That plus that divided by 2. The mode, there's no mode. And the mid will be this one plus this one divided by 2. Now, what I want you to notice is that the difference between the mean, median, and mid, it's not really that much. The mean is minus 0.15, the median is minus 0.23, and the mid is minus 0.39. And in fact, if I make more numbers here, these three will actually get closer together. In other words, there's special type of data whereby the mean, the median, and the mode actually they're all pretty similar. And the bigger the data set is, the more similar they are. And this data that behaves like this has a name. Does anyone know the name of this data? The name for data that behaves so that these three are nearly the same. That's it, normally distributed, or normal data. And the good news is, a lot of data behaves like this. So when you make a measurement in physics, it's like this. Which is good, because it means that this estimate is actually going to be, pretty close for a quick estimate. Yeah. So this type of data is called normally distributed, normal data. Yeah. Abnormal, not normal. Not normally distributed. Yeah. You knew of this before you heard it, yeah.
Oh really? There is a not normally distributed.
Oh yeah. There's actually many types of distributions. We'll only study one of them. So let me just tell you which ones you don't need to do everything on this page. I just need you to do the first 4 questions, and that's it. Yeah, I know.
Teacher, I need to go to my room to take book. It's already finished.
Go on.
What about making average among 3 of them?
What do you mean?
We have medium, mode, and average, and making them.
Oh, the average or the average?
Average. That would be weird average.
That would be a weird average. I don't think you would ever do this.
Because none of them is right and proper average.
Depends what your condition is for proper. To me, it seems proper to use median for income. Okay.